All right, so we're going to go over these 4 examples today. And for all of you at home, I will be reteaching this again tomorrow.
Could take it into school.
Yeah, that's okay. You should stay home. That was fun. Okay, but yes, we'll be going over mole equation all week, but these are just today's 4 examples. Okay, so we'll start out with number 1. Number 1 is very much like what we did last week. Okay, we're looking for how many moles. Okay, so the question is asking us to calculate N. Okay, it's telling us that the material is carbon dioxide, which will allow us to calculate the molar mass, okay, of the material. So we're going to have, oops. All right, so we have carbon dioxide, which obviously has 1 carbon and 2 oxygens in it. Okay, so we're going to go 12.01 grams per mole for the carbon, and we're going to go 16 times 2 for the 2 oxygens. So that's going to give us 44.01 grams per mole. Okay, so there's our molar mass.
My mom just texted me, she's outside.
Okay. Make sure you watch this at home.
Yeah.
Okay. Okay, so we also have the mass. They told us we have 150 grams, okay, of carbon dioxide gas here. So we have those 2 numbers. We're looking for N. We don't have to manipulate the mole equation in this example because it's already set up to calculate N. So all we have to do is plug in the numbers we have. 150 grams, okay, divided by 44.01 grams per mole. So that's grams per mole. Okay. So 150 divided by 44.0. So we have 3.41 moles worth of carbon dioxide here. All right, so that's the easiest example of a mole equation problem. Okay, easiest one, because we basically don't have to do anything except calculate molar mass and plug numbers in. Right? So likely that would be a 3-mark question. You get 1 for this, you get 1 for your mathematical operations, and 1 for your answer. Okay?
Would we get it wrong if we didn't put grams per mole like if
in
we
here?
put it in our answer, but if we didn't
No, I don't care whether your units are in here. I just put them in for explanation's sake. But yes, you do have to have it here on the final answer. Okay? Any other questions on that? Okay. So for question number 2, they're asking us to calculate the mass this time. So that's little m. Okay? And they tell us the number of moles, 26.5. And they tell us it's cobalt 2 bromide. So that'll allow us to calculate the molar mass. So cobalt with a 2+ charge, because that's what the Roman numeral tells us, and it's with bromine. So we're going to have COBr2. That's our formula. All right, so cobalt, 58.93. Okay, there's only 1 of them. And then there's 2 bromines, so 79.9 times 2. All right, so we're looking at 218.73 grams per mole for our molar mass. Okay, so we have the mole equation, N equals little m divided by big M, but we're trying to solve for little m. So we have to isolate it by doing a little bit of algebra. That means I have to move big M over to the other side so that little m is alone. Okay? Right now I'm dividing by big M, so the rules of algebra say to move something I do the opposite. All right, so I'm going to multiply this side by big M. Big M over big M is 1, so that cancels. And then what I do to one side, I do to the other. Big M multiplied on the other side. Okay, so now I have my formula solving for little m, so I can plug in my numbers. That'll be 218.73 molar mass, okay, times the number of moles, which they told me was 26.5. Okay, so we're probably going to have a lot here. Okay, probably going to end up being a lot of mass. All right, so we take that number, we multiply by the number of moles. All right, and we have 5,796.35 grams worth of cobalt to bromide?
Isn't it?
Hmm?
That's a lot.
That's 5 kilograms, well, almost 6 kilograms. Yeah. So, yeah, I mean, it's a pretty good amount.
Yeah.
Okay, questions on that one? All right, now we're going to look at two that we haven't done before. Okay, they're similar, but they have one extra step, and that involves using Avogadro's number. Right. So, quick review before we talk about that is right. Avogadro's number is 6.02 times 10 to the 23. That is the number of particles in 1 mole. Okay? So if I have 1 mole of something, I have this many of it. Okay? If I have 2 moles of something, I have twice that number. Okay? Everyone all right with that? So what we're going to do with this next question, okay, is we're going to have an extra step involving that number. All right. So the question says, how many molecules? Okay, so we're looking for the number of molecules here. That's not hashtag molecules, that's the number of molecules. Okay? All right. Of sodium sulfate. Okay, so sodium with sulfate. Sulfate's a -2, so this will be Na2SO4. Okay, are in 29 grams. Okay, so I have little m, and I have the ability to get big M, because I know what the material is. So let's get big M first. Okay, so we're going to have 22.99 times 2, okay, plus 32.07, right? Plus 16 times 4. 22.99 times 2.
It's sodium sulfide, not sodium sulfate.
Oh, good eye. Sodium sulfide, not sodium sulfate. That makes our life easier, actually. Okay, 22.99 times 2 plus 32.07. Okay, so there we go. I don't have to do all the oxygens. Okay, and I don't even have to change what I typed into my calculator, because I wasn't that far yet. Plus 32.07. All right, so we have 78.05. Grams per mole. Okay, so there's our molar mass. Now, I have big M and I have little m. The mole equation looks like this. Little m over big M. What can I calculate with those two numbers? I can calculate the number of moles. Okay. Is that going to be useful in calculating the number of molecules? Yes. Because if I know how many moles I have, and I know the number of particles in 1 mole, I can figure out how many molecules I have. Okay? In the same way that if I know there's always 12 donuts in a dozen, and someone tells me I have 4 dozen donuts, I can quickly figure out that I have 48 donuts, because I just multiply 4 by the number in a dozen, 12. Okay? I'm going to do the same thing here. All right, so let's calculate the number of moles. So the number of moles will be 29 grams divided by 78.05. So I have less than a mole. 29 divided by answer. All right, so I have 0.3715. I'll keep all those decimals, but I'm just going to write 0.372 on the board. Okay, 0.372 moles. Okay, and incidentally, you should keep all of your decimals until the very end of a calculation. Okay, then you can round, but you always keep all of your decimals, especially when we're multiplying by a big number like Avogadro's number. If I round off, it really can change my answer a lot. Okay, so we want to keep all of our decimals. All right, so now I have the number of moles. If I want to calculate the number of molecules, I take the number of moles and I multiply by Avogadro's number. Okay? And again, the reason I do that is this is the number of molecules, particles, in 1 mole. If I multiply by the number of moles, then I'll get how many molecules I have. All right? So what we're going to do here is we're going to take that 0.372 and we're going to multiply it by 6.02 times 10 to the 23. All right. Now, if you're to the point where you're trying to plug that into your calculator, you're probably going, how do I put that into my calculator? that big number. Okay, so I'm going to show you how. Your calculator either has a button that looks like this, or it has a button that looks like this. Or if you have a TI-83 or TI-85 or 120, whatever we're on now, okay, because there's like a whole bunch of them, okay, it's actually above the comma. So if you look at where the 7 is, there's a comma above the 7, and you can see the second function of the comma is two capital E's. Okay, so that's going to be our exponent button. I'm going to show you how that's going to work here right now. Right? So if I want to do this operation, I'm going to take that number there and multiply it by Avogadro's number, which needs to be enclosed in brackets. Right? So I'm going to put a bracket there and then go 6.02. Then I'm going to hit the second function button, or if you have an EXP button, you just hit that. Okay? And then press the comma, and I get an E. That E stands for times 10. Right? The next thing I'm going to put in is the exponent. So the E that I have on my calculator now means times 10. So I'm going to go E23. Right? That's how I enter in Avogadro's number into a TI calculator. Okay, so you go 6.02. Okay, so bracket, sorry, 6.02. Hit the second function and then the comma. That will put in a capital E that stands for times 10, and then whatever number you enter after is the exponent. In this case, it'll be 23. Okay? Everybody with me on that?
Couldn't you just manually enter 10 and then use the exponent function and enter 23?
I find people mess that up, because when they do that, sometimes they like, if you go times 10 and then you go power, sometimes it puts in an extra power. And I just don't want people to mess that up. Right? Okay. Okay, so when I punch that in, this is what I get. 2.24, we'll have to round, 2.24 times 10 to the 23. Okay. All right, so there's my answer, and my units are molecules. Right, so there's just one extra step. Yep.
You guys are
Oh, a bunch of quitters. That's good. Okay. I too have been hungry and I feel your pain. Okay. Questions on how that one works? Okay. So the last one actually goes the other way. The last example is they tell us the number of molecules and want us to figure out the mass. So the reverse of what we just did. Okay? So if we're doing the entire reverse of what we just did, instead of multiplying by Avogadro's number this time, we'll take the number of molecules and divide by Avogadro's number. And then we'll work backwards to get mass. Okay? So it's basically the complete reverse. Okay? All right, so here's our last example. We want to find the mass of 7.2 times 10 to the 23 molecules of diphosphorus pentaoxide. All right, so our givens are the number of molecules. 7.2 times 10 to the 23. Okay, we are looking for the mass, so we're looking for little m. And we know the material is diphosphorus, so P2 pentaoxide, O5. All right, so we're going to have 30.97 times 2, right? 0.97, right?
Phosphorus?
Yeah.
Oh, yeah.
Yeah. Okay, plus 16 times 5. So look at that. 30.97 times 2 plus 16 times 5. All right, so the molar mass of this stuff is 141.94. Okay, if I'm going to get little m, I need big M and I need N. Now, I have big M, but I don't have N. So what I'm going to do is I'm going to use the number of molecules and Avogadro's number to calculate the number of moles, N. Okay? Then I'll have it, and I'll be able to calculate little m from there. Okay? So all I'm going to do is this calculation to get n. I'm going to take the number of molecules, and I'm going to divide it by Avogadro's number. Okay? What I'm doing here is saying, I have this many molecules. I'm going to divide it by the number of molecules in 1 mole, and that'll leave me with moles. Okay? So like saying, I have 36 eggs. How many dozen do I have? So I go 36 divided by 12. Find out that I have 3. Okay? We're all right with that. That's what I'm doing here. Okay, so I'm going to go 7.2, right? 7.2 times 10 to the 23 divided by Avogadro's number. That'll give me my number of moles. It's going to be like 1 point something. Okay? All right, so to do that, we have to bracket both of those numbers. So I'm going to go bracket 7.2. I'm going to hit the second function and the comma to get my E. Okay, 23, end that bracket. Then I'm going to divide by Avogadro's number. So bracket 6.02, second function, hit the comma, okay, 23. Thanks. So I have 1.20, we'll say, moles. Again, I'm only rounding off on the board here because I don't want to write all the decimals. Okay.
Why do you have to use the brackets on the calculator?
Otherwise, your calculator will do order of operations. So if I punch in Avogadro's number without brackets and then put something after that, it thinks it's part of the exponent. And then it gives me really wacky answers. Okay, so I've got the number of moles now, and I have the molar mass. So now I can go back to the mole equation, because now I have this one and this one. Okay, so now I want to isolate m. I'm going to multiply both sides by big M. Okay, and that will give me my mass. So I'll plug in my numbers. Okay, that will equal 1.20 times 141.94. Okay, so we have 169.76 grams of diphosphorus pentoxide. Okay, that one would be a 5-mark question for sure. All right, you would get, okay, so stepping back here to the beginning, you'd get a mark for your givens and calculating your molar mass, right? You would get a mark here for calculating your number of moles using Avogadro's number, okay? You would get a mark for your manipulation, okay? That's we're up to 3 now, right? Okay, you get a mark for your plugging in of numbers, and a mark for your final answer. Okay? Those are the only 4 ways that I can ask a mole equation problem. Right? So I went over 4 today. I'm going to go over 4 again tomorrow. And I'm going to go over another 4 again on Wednesday. Maybe even on Thursday. Probably not. Thursday I'll do a unit exam review, because that's what I said I was going to do. Friday I'll probably go over 4 more. Okay? Mole equation examples. Okay? Just so we all know how to do this. Because on the test, you're going to get one of these. Okay? So you'll have one like the first one, one like the second one. Okay? So you've seen an example of all 4. Okay? I can't twist those in any way to make them more or less difficult than what I've shown you there. Okay? So if that makes sense, you can try some of the mole equation problems in the workbook. Okay? On Google Classroom here, it's the end of the chemistry workbook. Okay, so chemistry notes and worksheet package, and you want so the mole equation worksheet key is right here on the top right. Okay, so if you're wanting to see if you're doing them right, that's where the key is. Okay, but obviously the worksheet itself is here. It's the Google Doc. And it should be right at the end. So it starts right here. The mole concept worksheet. Okay, so you can start there. Okay, the first one is just basically asking you to do some Avogadro's number calculations. Okay, so you would take, if it's asking how many atoms are present in the following. How many atoms are there in 1 mole of gold atoms? 6.02 times 10 to the 23 is the trick. Right? Because that's Avogadro's number. But Avogadro's number is the number of anything in 1 mole. Okay? If I want to find out how many atoms there are in 2.5 moles, I take Avogadro's number and multiply it by 2.5. It's a pretty easy question. Basically, just multiply. Okay? All the way through on that one. Then it's going to ask you to do some mole equation ones. So number 2 is basically one manipulation, so it's n equals the number over big M. Then it asks you to calculate the mass in question number 3. Okay, and then there's some variations of different types of mole equation problems after that. Okay, that's what we're going to be working on all week. So if you don't feel like doing any of those today, you don't have to. Okay, but that's what we're going to be working on for the remainder of the week. And there's quite a few of them because there's a stoichiometry worksheet after that, and there's more. I always have lots. Okay, all right.